Hi guys, good to have you here. Thank you for joining us. If you're new to this channel, this is E Plus Academic Resource Center where we take online tutorials for undergraduate and senior secondary students, okay? All right, especially for social sciences and management sciences students, okay? Please, if you are yet to subscribe, kindly do so. Hit the notification bell so that you get notified when we upload new videos, and share this video, invite people to be part of what we're doing. All right? Okay, so today we're going to be looking at differentiation. We've done a bit of introduction in a TikTok page, okay? But here is going to be the full class where we'll solve one or two questions to help us understand it better, okay? So we're going to be looking at differentiation. Basically, we're going to look at differentiation from the first principle. Okay, from the first principle. All right. Okay, so now when we say differentiation, what's differentiation? Differentiation is simply the rate of change of one quantity over another. Okay, the rate of change of one quantity over another. So let's say we have a graph like this. Okay, we have 2 points on a graph. These are points. Let's say this, let's call these points P, and let's call this point Q, okay? So these are Y1, these are Y2, these are X1, okay, X2, X1. This is Y2 and Y1, okay? So let's say we have a point on our graph, points, we'll call this point P, point Q, okay? Now, M, which is the rate of change, which is also change in Y all over change in X, is equal to Y2 minus Y1 all over X2 minus X1, okay? M is our rate of change, which is the same thing as change in Y all over change in what? In X. Now, F, okay, F, okay, let's say Y is a function of X, okay? We have Y1 is also a function of X1, and Y2 is a function of X2, okay? Y is a function of X, Y1 is a function of X1, Y2 is a function of S2, okay? So, now the rate of change for X2 minus X1 is same thing as change in X, okay? X2 minus X1 is same thing as change in X. So therefore, if we substitute now, okay, let's make X2 here, subject of formula will have X2 is equal to change in X, okay, minus X1. Or let's put it this way. X1 minus change in S. Sorry, yeah, this is plus change in X, okay? X1 plus change in X. Are we together? Make this one subject of formula, then this one cross multiply, we have plus here. So Y2 minus Y1, let's substitute, okay? Okay, let's say we have, let me wipe this place off. Okay, now remember Y2 is a function of X2, okay? So we have F of S2, okay, minus Y1 is a function of X1, okay? Are we together? All over X2 minus X1. Now S2 is giving us X1 plus the X, X1 plus the X, okay, minus X1. X1 plus the X, let me write it properly, minus X1, okay, which is equal to, now X2, same thing as this, X1 plus the X, okay, minus F X1 all over Now this cancels this, so we have the x. Okay? Are we together? Now, this is the standard formula for differentiation from first principle. Now, if this point, when this point draws closer to this point, now the rate of the change or the rate of change of x tends to be equal to 0. Okay? So at that point, at that point, change in x is set at, the limit is set at 0 to give us a more accurate result. So the y dx, okay, when limit is set at 0, okay, change in x is set at 0, when it tends to 0, okay, we have fx minus 1 dx minus fx1 all over dx. So this is the formula for finding a derivative from the first principle. Now we're going to solve one or two questions to help us understand it. Okay? So let's say question 1, let's solve y equal to s squared. Okay? You know it's same thing as fx. Okay, same thing as okay. Y equal to s squared. Okay, it's same thing as saying fx equal to s squared. Okay? Remember, x is a function of f. Okay? All right, so now we apply our formula. Okay? S squared will now be x1 plus the x, okay, square, okay, minus x squared all over the x. Are we together? Now, this one will open up. The same thing as saying x plus the x, okay? Same thing as this, okay? Minus s squared all over the x. We just open this up because of this square, okay? So when we open up the brackets, we have x bracket, x1 plus the x, close bracket, then plus the x, open brackets, x1 plus the x, okay? Minus s squared all over the x. S times this, we have s squared, okay, plus x the x, that is this times this, okay, plus the x times this, we have x the x, okay, this times this, we have plus the x squared, okay, minus s squared all over the x. Are we together? Now, x squared, okay, plus x dx plus x dx, you have 2x dx, okay? Sorry. Let me come up. We have s squared, okay, plus x dx plus x dx will give us 2x dx, okay, plus the s squared, the x squared, okay, minus s squared all over the x, okay. So this will write off this, plus s squared minus s squared will strike off each other, okay. So we're left with 2x dx, okay, plus the s squared all over the x, okay. So there's a common factor on this part, so we have the x as a common factor, so we have 2x plus the x, okay, all over the x. okay? The x will strike off the x. Are we together? So we are left with 2x plus the x, okay? Now, when limit is set at 0, limit of the x is set at 0, we have 2x plus 0. We substitute 0 for the x, okay? Are we together? So we're left with 2 what? X. So the derivative of x squared is equal to what? 2x. Now, this leads us to the differentiation by rule, which also can be written as change in y all over change in x is equal to n x raised to power n minus 1, okay? Which this one, okay? Now, from our question, we have s squared, right? So, using the rule, differentiation by rule, okay? Differentiation by rule. If we should apply this differentiation by rule formula, we have 2x raised to power 2 minus 1, okay? So, 2x, 2 minus 1 is 1, which is equal to what? 2x. And that's the same answer we got using the differentiation from first principle. Are we together? So, from differentiation from first principle, that leads us to differentiation by what? By rule. So, either you use, okay, for instance, if I say 3s squared, differentiate 3s squared. Using the differentiation by rule, we'll have 3x squared will be equal to, okay, 2 times 3x raised to power 2 minus 1, which is equal to 2 times 3, which is 6x raised to power 2 minus 1 is what? 1, which is equal to 6x. Okay, so that is all about differentiation from first principle. We have our formula, and this is how you substitute your formula. So if you want to use differentiation from first principle, for instance, to solve for y equal to 3x squared, so you will have the formula goes like this, right? Minus fx all over dx. So you will have 3, then the function of x, which is x plus the x, yeah, minus 3x squared, okay, all over dx. Then you solve. Okay, this is how you solve for 3x squared using the first principle. You substitute like this. So if we should interpret using our graph, we'll have something like this. We should interpret using our graph for y equal to s raised to power 2, okay? We'll have something like this, s squared, then x plus the x squared, okay? These are x, then x plus the x, okay? Remember how we got this. This one is same thing as x, same thing as x2, okay? Remember, the change in x is equal to x2 minus x1. So these are x2, these are x1. So our y is equal to x raised to power 2, which is this. Okay, y x dx is the function of x raised to power 2. Okay, so that is how you go over differentiation from first principle and by extension differentiation by rule. There's nothing much about differentiation from first principle. It's very easy to navigate, and you know, with this 1 or 2 questions we have solved, it will help you get your understanding about it very well. All right, guys, we're going to stop here for today. Thank you for staying to the end of the class. Subscribe if you have not done so. Hit the notification bell so that you get notified when we upload new videos. All right, thank you. See you in the next class. Bye bye for now.